Hello and welcome to IT is Great, Grade 10 IT syllabus. In this video, we'll be talking about data as the computer sees it, Module 4.1. We'll be talking about number systems, data storage, and finally we'll end up with the glossary. Number systems. Computers work in only two states. Something could either be on or off. That is, it could be true or false, yes or no. This is interpreted in terms of the binary number system, base 2, either a 0 or a 1. The other number systems that you've worked with is base 10. That's the decimal number system. In the decimal number system, we have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In the binary number system, we have the digits 0 and 1. In the hexadecimal number system, you have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. In the decimal number system, this is represented as 2358. In the binary number system, this number is 1010101 to base 2. In the hexadecimal number system, this is A2CD3E base 16. Now, when you were working in the decimal number system, a number such as 4192.304 would have been represented as 2, and that's 90, and that's 100, and that's 4000. In terms of place value, in terms of the decimal number system, this is 10 to the power 0, 10 to the power 1, 10 to the power 2, and 10 cubed, which is 1000. And that's 100, and that's 10, and that's 10 to the power 0, which is 1. 0.3, which is 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3. That's where it's written out here. Similarly, we look at what would happen in the binary number system. Now, if you had to expand the decimal number 4192.304, it will be 4 times 10 to the power 3 plus 1 times 10 squared plus 9 times 10 to the power 1 plus 2 times 10 to the power 0, and so on and so on and so on. Let's go to the next slide. Here's the binary number 1101.101. Similar to the decimal number system, this used to be 2 to the power 0, 2 to the power 1, 2 squared, 2 cubed. After the decimal point, it will be 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3. Let's not call this a decimal point, let's just call it a point, right? Let's go on. In the hexadecimal, which is base 16, this is 16 to the power 0, 16 to the power 1, 16 squared, 16 cubed. What's so important about binary numbers? Engineers discovered that it was easy from a physical engineering point of view to have just two states, on and off. This could easily be represented by the presence or absence of current flow. Data is now represented in terms of zeros and ones. Converting from another number system to decimal number system. When converting from a binary numbers to decimal numbers, we like to think of writing it in expanded notation. This is 1 times 2 to the power 0, 0 times 2 to the power 1, 0 times 2 squared, and 1 times 2 to the power 3. 2 to the power 3 is 8, 2 squared is 4, 2 to the power 1 is 2, 2 to the power 0 is 1. Converting from a hexadecimal to a decimal number system. Again, writing it in expanded notation, 3 times 16 to the power 0, f times 16 to the power 1, 2 times 16 squared. 16 squared is 256, 256 times 2 is 512. F is represented as 15, 15 times 16 is 240, 16 to the power 0 is 1, 3 times 1 is 3. Add that up, 755. Converting decimal to another base. Let's take the value of 634. Let's divide by 2, because that's the base we want to convert it to, binary. You have 317 remainder 0. You take 317 and you divide it by 2. You're going to get 158. Remainder of 1. Take 158 divided by 2, you're going to get 79. Remainder 0. Take 79 divided by 2, you're going to get 39. Remainder 1. 39 divided by 2 is 19. Remainder 1. And you go on and on and on until you come to 1 divided by 2 is 0, and you say remainder 1. Now you read it from the bottom going up. So it's 1 0 0 1 1 1 1 0 1 0. All of that is to base 2. Converting decimal to another base. 634 to divide by 16 is 39, remainder 10. 39 divided by 16 is 2, remainder 7. 2 divided by 16 is 0, remainder 2. Read it from the bottom going up. 2, 7, 10. 10 is A in base 16, the hexadecimal number system. So the answer is 27A base 16. Data storage. What's bits and bytes? Each of these data types is allocated a fixed number of what is termed bytes. Each byte, a number in binary format, for example 10110011, consists of 8 binary digits or bits. 8 bits make a byte. Here is an example of data stored in 4 bytes of 8 bits. That is 32 bits. Here's 1 byte, another byte, another byte, and another byte of data. Primitive data types. You have common data types as integer or a whole number, a real number, string, or text. Delphi and Java. Let's compare data types. A byte has an allocation of, we would say data type byte 1 ranges from 0 to 255. Short integer, and integer int64. In Java it will be known as a long integer. Data truncation. Truncation means to basically cut off. So when you say cutting off the data, some of the text is lost. Reliability of data loss of accuracy. Each program or program languages uses different numbers of bytes to store data. Decimal or real numbers are normally stored in 2 parts, the number and the exponent part. 3.1415, 3.14, that sounds familiar. Multiplied by 10 to the power 12. Accuracy in the exponent part would be critical. A loss of accuracy in the number part would lead to a loss of accuracy in the number of decimals. Storing non-numerical data. There we'd use a coding scheme. The ASCII system was the original standard which assigned numeric values to letters, digits, punctuation marks, and other characters. ASCII stands for American Symbolic Code for Information Interchange. Almost at the end, storing non-numerical data. A picture is basically a collection of thousands of dots, or pixels, each of which can be modeled by representing its position and color. Then we digitize any picture or video. Music too is modeled by representing the data as numerical values, describing volume, pitch, and frequency. And that covers this module, how the computer sees data. In terms of glossary, go over words like ASCII, binary, what's a bit, what's a byte, coding scheme, hexadecimal, octal number system. Oh, we didn't cover that. And the decimal number system. I hope you like it. All the best. Make sure to subscribe to my channel. Goodbye.